Alright, welcome back everybody. In this video we're going to be discussing information from section 6.10 of AP Calculus, integrating functions using long division and completing the square. So it is exactly what it sounds like. We're going to integrate functions. In some cases we're going to use long division to simplify the integrand before we integrate, and in some cases we're going to use completing the square. So let's get right down to it. The first technique, using long division, and hopefully everybody remembers how to do long division from before. If you don't, you'll get a quick little refresher while we do these problems. But generally this technique is used when we have a rational function as our integrand, which you see here, and the degree of the polynomial in the numerator is, it says here larger. I'm actually going to say larger than or equal to. There are some problems where the degree of the numerator might be the same as the degree of the denominator, where we can use long division. And then, secondly, when we do this, the result of this integration typically results in polynomial terms and a natural logarithm. Okay? So first things first, the bulk of what we're doing here, the calculus isn't very difficult. The more difficult part is the algebra. So first I'm going to go ahead and do the polynomial long division and divide x plus 5 into 3x to the third plus 14x squared minus 4x plus 1. And so I need to figure out what I multiply by x to get 3x cubed. That's 3x squared. Then I'm going to multiply 3x squared times the x plus 5. And then I'm going to subtract that away and drop the next term. I try to figure out what I multiply by x to get negative x squared. That's negative x. I multiply, and then I subtract that away. Gives me x. Drop the next term, and then this is 1, and 1 times x plus 5 is this. And then I subtract, and I have a remainder of negative 4, so this is going to be minus 4 over our divisor. And so my original integrand here can be rewritten as the integral of 3x squared minus x plus 1 minus 4 over the quantity x plus 5. And now I'm just going to go ahead and integrate this thing term by term. The integral of 3x squared is x cubed. The integral of minus x is minus x squared over 2. The integral of 1 is x. And the integral here is 4 natural log of the absolute value of x plus 5. Don't forget your plus c. And boom, there's my integral using long division. And as promised, polynomial terms and a natural logarithm. Let's go ahead. We'll look at a second example here. In this case, the denominator is x squared plus 4, but still, we've got a polynomial and the degree is smaller than this, smaller than the degree in the numerator. So we're going to go ahead and do some polynomial long division. And we've got, let's see, 3x to the third minus 2x squared plus 12x minus 7. And let's see, I need to multiply x squared by 3x to get my first term here. So I'm going to multiply that by 3x to the third plus 12x. Ooh, that's exciting. Leaves me with negative 2x squared. And I'm going to drop the next term. And then I need to multiply x squared by minus 2. That gives me negative 2x squared minus 8. And I end up with a remainder of positive 1, so that's going to be 1 over x squared plus 4. Okay, so this integral can be simplified to the integral of the quantity 3x minus 2 plus 1 over x squared plus 4. Now, since this is not a linear term in the denominator, this one will not result in a natural logarithm. I forgot what a natural logarithm was called there for a second, pardon me. All right, so I'm going to go ahead and take the antiderivative of these first two terms, 3x squared over 2 minus 2x, and now this last term here, I'm going to handle this using substitution. And this reminds me of an arctangent, and this, I've got a constant over something squared plus something. My technique for dealing with that was I made a substitution where I would get the coefficient of this term to be the same as the constant. So I'm going to replace x squared with 4u squared. So I'm going to replace x with 2u, or u equals 1/2 x. Dx is equal to 2 du in that case. Splashing information there. And now that's going to make this. I replace the dx with a 2 du. And I replace the x squared with a 4u squared. And now I can factor Now I can factor a 2 over 4 out of that fraction. And it turns into that. And then the antiderivative of that is going to be the arctangent of u. And now bringing u back. So even when we're solving these integrals using long division, we're going to use other techniques we've already learned, basic antiderivatives, substitutions, some of the more challenging substitutions, and we'll go from there. All right. One more example on the long division realm, showing that, hey, guess what? We can do this still as a problem involving a definite integral instead of just an indefinite integral. So we can apply this technique to definite integrals as well. I'm going to go ahead and perform the long division first. So we need to multiply that by 6x squared. Do our subtraction. And negative 4x. And plus 3. And minus 1 over our divisor. And so this is going to turn into the integral from 0 to 3 of the quantity 6x squared minus 4x plus 3 minus 1 over the quantity x plus 2. And then I'm going to go ahead and find my antiderivative. And so let's see, that's going to be 2x cubed minus 2x squared plus 3x minus the natural log of the quantity x plus 2, which I'm going to evaluate from 0 to 3. And so this will be 2 times 3 cubed minus 2 times 3 squared plus 3 times 3 minus the natural log of the absolute value of 3 plus 2 minus 2 times 0 cubed minus 2 times 0 squared plus 3 times 0 minus the natural log of the absolute value of 0 plus 2. And so let's see, this turns into 54 minus 18 plus 9 minus the natural log of 5 minus 0 minus 0 plus 0 minus the natural log of 2. And so this turns into, 3645 minus natural log of 5 plus natural log of 2, which using exponent properties turns into, logarithm properties, turns into the natural log of 2 over 5. Let me clean that up a little bit. I wrote that natural log so high. Oh my. Oh no, we've crashed. Be back. Sorry about that. My presentation software crashed because I tried to do something so daring as erasing. So anyway, I can simplify the minus natural log of 5 plus log of 2 as natural log of the quantity 2 over 5. And so there's my final answer for that definite integral. All right, we're going to go ahead and call it quits there. And we're going to come back with a second video on this topic where instead of doing long division, we're going to handle problems that involve us completing the square. Okay, see you then, and have a great rest of your day. Goodbye, everybody.